Okay, so example 2, I'm skipping it because I got a little bit ahead of myself. Example 2 is just this aside that I did. Example 3 involves the complex sine and cosine, which we haven't talked about because I want to get through chapter 5 in this semester. So we're going to do a modified example 3. So this is number 6 in the problem section. So example 3, uh, notice that we haven't been given a contour, and that's because the function that we have, this function 3z squared minus 4z plus 5i, this is analytic, so in particular continuous on all of C, and it has an antiderivative. So the antiderivative is what you think it is. It's z cubed. Sorry, it looks like z times 3. Z cubed minus 2z squared plus 5iz. That's our antiderivative. And so we can use the fact that it has an antiderivative to compute this integral. So the integral from negative 2i to 1 of 3z squared minus 4z plus 5i dz is just take our antiderivative and evaluate at the endpoints. Now, at this point, we all know how to do complex arithmetic, so I'm not going to evaluate that for us. But you plug in 1. Well, okay, I'll write out one step. We'll plug in 1, and we're going to subtract off plugging in negative 2i. And I'll leave it to you to determine what this is as a complex number of the form a plus ib, but I'm not gonna do the arithmetic after that point. And that's it. So we check that our function is analytic, and then we just go do computing, and it's not harder than that. So maybe since this was a short video, let's do just one more real quick. So let's see, let's do 11 from the book too. So this is number 11. So in 11, we're going to integrate 1/2 to I e to the pi z dz. All right, so e to the pi z is continuous. What's analytic? So this is entire. Let me just say that. So in particular, it's continuous. Differentiability is stronger than continuity, and it has an antiderivative. And the antiderivative is 1 over pi e to the pi z, as you would expect. So to compute this integral, all we need to do is we need to take our antiderivative, and we evaluate at the bounds. All right, so it's going to be 1 over pi e to the pi I minus 1 over pi e to the pi halves. And this one I will compute just because e to the pi I is familiar. E to the pi I is -1, so we get -1 over pi minus 1 over pi e to the pi halves. Okay, and so we have our two computations that we did here. Again, if you have an antiderivative, then you just do a fundamental theorem of calculus thing to compute the contour integral.